Welcome back to Shiksha Dakasa. Today we're going to be learning about populations and samples as part of our unit on working with one variable data. So today we're learning how to gather information about a large data set. We're also learning how to do something called extrapolate data to draw a conclusion. To extrapolate means to take the data that you have and learn something from it so that you can make predictions about something in the future. How do you know that you're good at this? When you can explain what is the distinction, what is the difference between the terms population and the term sample. When you can describe the characteristics of a good sample, and when you can even explain why sampling is even necessary. Also, when you can describe and compare different sampling techniques. And finally, when you can collect one variable data, so nothing too complicated, just one variable data, and do this from primary sources, so not looking up what someone else has researched, make up your own research. And you will do so using the appropriate sampling techniques in all sorts of real-world situations. And then finally, organize and store the data that you have collected in a way that makes it super accessible and easy for you to analyze and manipulate. So to start us off, let's get our minds in the right groove here. Santiago has a group of 5 friends that get together to play board games. And he's planning on organizing a public event for over 50 people, so 10 times his normal group size, 50 people to get together, and he will be the one supplying the games. But he's saying to himself, he's wondering, how long will people want to actually play a game? Some people don't want to play a long game. Some people want to go in and out and hop between games. Some people love to sit down there and really play a game for hours and hours and hours. So what is something he can do to figure out what will the people that are coming to this event, how long will they want to sit and play a game? How will he find out that information if he can't contact them in advance? So he wants to make sure that for all the 50 people coming for his event, that he is bringing the right games for them. He doesn't want to bring games that are too long. He doesn't want to bring games that are too short. How can he figure out what games to bring? If he can't ask the people in advance, he doesn't know who's going to come yet. How can he figure out what are the right games that he should bring? One thing he can do is he can start to just ask his 5 friends. He can ask his little group, what do they like? This is called taking a sample of a population. What is a sample? What is a population? A population is a group of people or objects or whatever that you are collecting data on. Now, obviously, Santiago can't collect data on everyone that is coming to his event, so he will take a sample. And a sample is a smaller group of people, objects, or whatever that represents the population. In this case, the 50 people that are coming to his event are the people that he wants to know something about. He wants data on them. And to collect data on them, he will take a sample, and the sample will be his 5 friends, because those are the only people that he has access to. So how long should these games be based on Santi's friends' responses? You can see they've given all sorts of different answers here for how long they like to sit down and play a game. And this is continuous data, because any of them could have used a decimal to describe how long their favorite game is going to take. They could have said 3.5 minutes if they wanted. The fact that they chose whole numbers doesn't really mean anything that it's discrete data just yet. So how do we find out how long the games that Santi should bring for all 50 people, how long should they be? Well, they should fall within 1 standard deviation of the mean of the data. And if they do that, then 68% of people will enjoy themselves at this event. What is the mean of this data? Well, if we add up all of these numbers and we divide it by 5, we'll find out that the mean is 108 minutes. So Santi's friends on average, they like to sit down and play a game for 108 minutes, which is just a little bit under 2 hours. When we take these numbers, 60, and we subtract them from the mean, and then we take that number and square it, so if we find the square differences, these are the values we get, And now when we're looking for standard deviation, we find the mean of all of these, except because we are using a sample, instead of adding them and dividing them by 5, we'll divide them by 1 less. We'll divide them by 4. And that's part of the formula for standard deviation. If you are finding the standard deviation of a population, you just need to find the mean of these. But if you're trying to find the standard deviation of a sample, you divide it by 1 less. And that increases the sort of size of a standard deviation. And that's to account for the fact that, hey, you might have made a mistake here just because, because you're not sampling the whole population, you want to give yourself a little bit more room for error. So instead of dividing by 5, you divide by 4, which makes this number a little bit bigger. The size of a standard deviation gets a little bit bigger. Now the difference is squared equals 2070, but I'm not looking for the standard deviation squared. I'm looking for the standard deviation. I'm looking for sigma, so I need to get rid of this square. The opposite of a square is a square root. And so if I square root this side, these two operations, because they are the opposite of each other, they will cancel each other out. And then what I did to this side, square rooting it, I have to do to the other side. And I'll square root 2070 and find out that sigma, my standard deviation, is about 45. So we'll round that number to about 45. And what does this number mean? Well, the lower limit of a standard deviation is found by taking the mean and subtracting the size of one deviation. So 108 minus 45 is 63. And the upper limit is found by taking the mean and adding the size of one standard deviation. So 108 plus 45 is 153. And that means that if 50 people come to this event, and we assume that that data is normally distributed, the mean is 108 minutes. According to this sample, one standard deviation less than that is 63, and one more than that is 153. So what this means is this would represent 68% of players, of how long they would like to spend on a game. So Santi should bring games that are between 63 minutes and 153 minutes. He shouldn't bring anything that's less than an hour, and he shouldn't bring anything that is more than about 2.5 hours. Because most of the people, 68% of the people, like games that are between these two limits. And that way most of the guests will enjoy themselves. So before we start to really deconstruct what we did here about populations and samples, what are some downsides of Santi using a sample like this? Some of the downsides for using a sample like this is that Santi has only asked his 5 friends, and he's using that information to learn something about 50 people. And his friends may not represent everyone really well. So his friends are veteran players. They play board games like every week or whatever, right? People who like to play games for, more frequently, they might like longer games than people who just like to play a casual, quick game. Notice that none of them said less than 60 minutes. Whereas there are people out there who might want to join a game for just 10 or 15 minutes. And that way they're finished with the game. If they like it, they can keep playing it again and again. And if they don't like it, they can move to a different game. So Santi's friends might not, his sample of just 5, they might not represent the rest of the 50 people very accurately. So that's one part of our lesson today, learning about what is a sample and what is a population. So a population is a group of people or objects that you want to learn something about. And if you can't survey or study all of the population, you might choose a smaller group of that, which is a sample. A sample is a smaller group within the population that could represent it. A good sample has very similar characteristics to the population in very similar proportions. When we have a good sample, one that can represent the population really well, we can do something called extrapolate. We can use samples and extrapolate data about that population if we are not able to collect data on the population itself. Now, a population can be any number of anything, right? If you're learning something about all human beings, then you probably want 8 billion people in your population. If you're trying to learn something about just the population of Canada, the population size would be about 35, 36 million. If you're trying to learn something about just the people in your class at school, maybe that number is just 15 or 20. So a population can be any number. A sample is just a smaller number within that population. And if that sample does a really good job of representing the entire population, then you can extrapolate. To extrapolate means to make a prediction about something that you don't have the full information on just yet. So just like Santi, he's using his friends as a sample to extrapolate what the population would like to play. Taking a good sample is important if you want to try to make those predictions. Santi's sample was not good. It was not great. Most people don't play as often as his friends, so his sample did not represent the entire population very, very well. So instead of doing what he did, we can use very proven, tried and true techniques to try to get a good sample. And here we will learn a few of those techniques. The first one, and the easiest one, is called simple random sampling. This is kind of like taking names out of a hat, right? You don't know which one you're going to pick. Everyone has an equal chance of being picked. You are just choosing random members of the population. So if these were the 50 people, you might choose 5 random ones like this. Everyone had a chance of getting picked, and that's what makes this fair. Okay, it's simple and it's random. But there is a chance, it's a low chance, but there's a chance that you could pick the first 5 just by coincidence. So simple random sampling is a good way to start, but it's not a good way to make sure that your sample is fair. To do that, we might need a little bit more advanced sampling, like systematic sampling. In systematic sampling, we order the population somehow, and then we choose members at regular intervals. So if we had 50 people, we might choose every 10th person. That's the 10th, the 20th, the 30th, the 40th, and the 50th. And this makes sure that we are choosing a member of the population from all over the population, not just the ones that are closest to us. Systematic makes sure that our samples are nice and spread out. We could also do something called stratified sampling. In stratified sampling, we group the population by a certain characteristics. And then in our sample, we have to make sure that we are selecting members in the same proportions that characteristics separated our population by. This will make sure that your sample's proportions match the population. So for example, if we had 50 people and 10 of them were red people and 20 of them were blue people and 20 of them were green people, and here I'm just using these colors, but that could be any characteristic, right? Then we want to make sure that, okay, 10 out of 50 is 20%. So 20% of our sample should be red. 20 out of 50 is 40%. So 40% of our sample should be blue. And again, 40% of our sample should be green. So just looking at this here, how many members should we select from each group if we want 5 members in our sample? Think about that for just a minute. I would choose 1 red, 2 blue, and 2 green. And this would make sure, right, that 1 out of 10 red people, that is 10% of the red people. 2 out of 20 is also 10%. And 10% of the green people would also be 2. Notice that I have taken the percentage that I want. So my sample of 5 represents 10% of 50. So I want 10% from each group. 1 plus 2 plus 2 will be total of 5. cluster sampling. In cluster sampling, we group the population, and then we choose a number of groups to be our sample. What you'll do is you'll end up collecting data from the entire group, but some of the groups won't have any data collected at all. So for example, if these are 50 people, we might make these 10 groups. And we might select, hey, I want this group and I want this group. Now, every member from that group will be sampled. But there are certain groups that never get sampled. So if this was maybe a school, you might group by classes, right? This is one class, this is another class, and maybe you don't have time to survey the entire school, so you choose to only go to certain classes and ask them to complete your survey. That would be cluster sampling. Next up is voluntary response sampling. And in voluntary response, you allow participants to choose, do they want to answer or not? And so you still might end up getting a random number of people that might answer your survey, but you typically would only get people who really have strong opinions. Voluntary response can be very divisive. Only the people, often the only people that respond are either heavily in favor or heavily against what they're being asked. So maybe these two people hate, maybe this survey was about, do you like chocolate? And these two people hate chocolate. They were like, no, I want everyone to know that chocolate sucks. And these three people love it. And so they might say, yes, I want everyone to know that chocolate is amazing. I'm so happy to share my opinion on chocolate. This person's like, I don't really care either way, so I'm not even going to answer this survey. This person is like, ugh, I hate when people ask me surveys, so I don't want to answer. I don't like it. Unless I really care about this topic, I'm not going to answer. And maybe this person is feeling sleepy or lazy, and they're like, I might do it some other time, and they never get around to it because they don't care enough about the topic to answer. So this is a problem with voluntary response. You might only get people answering who are really, really for or against the topic. Our final method is what Santi did, and this is called convenience sampling. You choose members of the population that you can easily access, and because of this, sometimes the results can be unreliable, but it's cheap and it's easy to do this. So what Santi did is he picked the 5 friends that he could access, the ones that he was closest to, and he didn't bother with the rest of the 50 people. So now we're going to try and create a survey together. Okay, and I'm going to do an example here, and then I'll let you try to make one on your own. What is something that we might want to learn about is sort of the first question we ask ourselves when we're making a survey. What do we want to know? What would the population be? We want to learn something about a lot of things. Now, that could be people, but it doesn't have to be. It could also be maybe animals, or it could be something non-living as well, like rocks. You might take a sample of a few rocks from your playground to learn something about all the rocks in your playground. One of the things we could ask is, how long does a grade 11 student spend on homework each night? In this case, what would the population be? In this case, we want to learn about all grade 11 students. And we could take a sample to learn about them because, we can't contact every single grade 11 student that exists. We might take a sample of that, maybe using our classmates, and that would be sort of like convenience sampling. To accurately represent the population of all the students, we may want to try to stratify our data by a characteristic, such as gender or even socioeconomic status. Maybe some students, when they go home, their home life is a lot busier than other students who have time to spend on their homework. Maybe some students have to take care of their, younger siblings. Maybe they don't have a quiet space to study, so they are unable to study at home. We have to consider stuff like that when we're learning about, when we're collecting data about a population. So maybe we want to stratify it. Maybe we want to do that by gender or socioeconomic status or anything else. Suppose these are our 11 students here that we have in our class, and we might want to use this as a sample to represent the population of all grade 11 students. And suppose we want to stratify that data by gender. Now we know that about half of everyone is male and about half of everyone is female. And so we might take this sample and we might notice, okay, I've actually got 6 girls, and 5 boys. If I use the entire class as my sample, the female perspective would be overrepresented, right? They would not represent the population very well because there would be more females than males in my sample. So what I might do is separate my, the people in my sample, and then I might choose to take 5 out of each. So I will definitely take all 5 boys, but I'll only take 5 out of the 6 girls, and I'll mix them up so I don't know which ones I'm picking. And now I've got 5 girls, 5 boys. That represents half and half of the population. And now we can make a survey and send it to all 10 of our respondents. And if we get an answer from all 10, then we know that our data represents our population's gender pretty well. Now, of course, this does not include people who do not fall into, either of these 2 categories. This does not include non-binary folks or two-spirited or trans, however they might identify. And because those people who identify as that are relatively rare, it may still be worthwhile to at least capture this data. But because people who don't identify in one of these 2 binary ways are also underrepresented in the population, we also have to be really sensitive because that means that they are what's called marginalized, that their voice is often silenced because people just say, you know what, they don't make up a lot of people, like they don't make up a big portion of the population anyways, so I'm not even going to bother with asking them. Even if they are just sort of 0.1% of the population, that's like 1 of every 1,000 people. I don't have 1,000 students to ask, so I'll just forget about them. That's not what you should make sure that you should try to make sure that their voice is also heard when you're stratifying in this way. And that's just a very specific case of marginalized people. You might stratify by socioeconomic status, and you might not be able to access people who are homeless, or you might not be able to access people who are extremely wealthy because they don't want to do your survey. You have to consider that your data does not represent the entire population because it did not give those groups a chance to be represented in your sample. Okay, let me make my survey now. So the first thing I'll do is the first thing you will do is create your own survey question that maybe you can use your classmates as a sample for, or maybe you can use your family or friends. You don't have to use all of them. You can be very selective about who you want to choose to give your survey to have your sample be very representative of your population. The answer to your question, whatever your survey question is, it can either be categorical data, or you could ask a discrete or continuous numerical data type question. So my question was going to be something like, how many minutes do you spend on homework each night? And that would be continuous numerical data. Somebody might say 3.5 minutes. They might say I may spend 20 minutes. That number could be a decimal. But you may want to ask something very simple, like what's your favorite Avenger? And in that case, it's not discrete or continuous data. That's categorical data. You might say, oh, I like Thor, I like Iron Man, I like Captain America. Those are just a few options. So that would be sort of like a multiple choice question. Your question can include any data type that you want, as long as you know what to do with that data type. So you can create your own question on Google Forms, and you can scan this to access the Google Forms application. And then once you're done creating it, send it to your classmates. You just have to make sure that under the responses section, you have clicked accepting responses. That's on, so that people can actually respond to your survey. And once you're done, click on this button here that says link to sheets. And what that will do is it will automatically take your respondents' answers, and it will put that data into a spreadsheet for you. You don't even have to do that work. Once it's in a spreadsheet, you can sort or filter your data, or you can even turn it into a chart. So in this lesson, what we learned is a lot about populations and samples. We learned what a population is, we learned what a sample is, and we learned what a good sample is. And now we learned that some of the sampling techniques that you can use are simple random, systematic, stratified, cluster, voluntary response, and as a last resort, convenience. You can use Google Forms or any other survey apps to collect primary data very easily. And this is better than doing it by hand because it automatically will take that data and put it into a spreadsheet for you. And you can use the data in the spreadsheet to instantly create charts and graphs and to calculate standard deviation and average and mean and median and all sorts of measures of central tendency and spread. Let me show you a quick example here. So the first thing that you would do when you're collecting primary data like this is you would create a Google form. So I would go to that link, forms.google.com, and I would maybe create a survey that looks like this, homework survey. And I would click on this plus button to add a question. And the question is, how many minutes do you spend on homework each night? Now, some people might want to answer, I don't know. And that will mess up your survey, right? You don't want them to give you an answer that isn't numerical. I want my answer to be numerical data only. So I will change my type of question to short answer. It's not multiple choice, it's short answer. And so they can put whatever they want in here. Now they could still put I don't know, or they could put 17 minutes, and I can't average it. The formula won't work if there's a letter in there, if I want to average it later. So instead, I click on this button down here, these three dots. First, I make sure the question is required, so they have to answer it. And I'll click on these three dots, and I'll check off this button called response validation. That means that their response has to be valid. They cannot put letters or numbers in it. And the way I specify exactly what type of response I'm looking for is I click on this, so number, and it is a number. And then I click on this little drop down. And that makes sure that whatever my respondents are answering, it will not allow them to press submit if the answer is not a number. The next thing I'll do is send out the link. So I will click on that responses button, and I will press this button up here that looks like a little paper airplane, like you're sending the survey, it's flying out to people. And I will click on this button here to get a link for it, and I'll copy that link. Okay? And then you can either click send, or you can enter their names or email addresses here. If I want to send out a link, I can of course do that. And once I've got all of that, I'm going to look at my responses in Google Sheets once they've all answered my survey. How do you do that? Well, you click on the button up here that looks like the word responses. And remember, I mentioned you have to click accepting responses, otherwise they won't be able to answer. And then you make sure that you click this button link in Sheets. And if you already have, now it will say view in Sheets. And if you click on it, it will take you directly to a Google Sheet. Notice it says homework survey responses. And it gives me the time that every single person answered my survey. And it gives me all of the data in a nice table already. I didn't have to do any of this work myself. But I can use this to very quickly make a chart and calculate all sorts of stuff. So I'll select all my data. I will click Insert, which is up here, and then Chart, which is right here, and then I'll select a histogram. Okay, I'll make sure that I have a histogram selected because my data is continuous. If your data is not continuous, if you've chosen categorical data, you may want to choose a pie chart or a column chart. And then I will use this formula to calculate the standard deviation. And this is how I do it. I go to a different cell and I press equals to let the spreadsheet know I'm going to start typing in a formula. This is the formula for standard deviation, SDDEV-A. This is the standard deviation of a sample, not of a population. So it will automatically calculate standard deviation. You can see here that inside the brackets, I have put B2 to B11. Those are all the cells that contain my data. I want to find out what is the standard deviation of all of this data, And when I press enter, it will tell me exactly what you see here. It is about 22.64. And then I can use the formula average. So you can see I pressed enter and there's that number, 22.64. That's my standard deviation. And in the next cell, I've put in the formula equals average. And again, inside the brackets, I have put B2 colon B11. So all the cells from B2 to B11. You notice that it's orange over here in the formula, and these cells are surrounded by an orange border. That's because I've chosen those cells to include. I want to find out what is the average, and when I press enter, it'll tell me the average is 78.7.
If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.